Oh, jeez. We're getting bilingual. Here we go. Find arc measures. Arc measures are not that bad. An arc is basically just a portion of a circumference. An arc is the piece of the outside of a circle, but not the full circumference. Vocab you need to know. You don't have to write all this down, but you do need to know it. Central angle is the angle from the angle formed by two radii that form your arc. See how those are both radiuses? Well, that angle right there is the central angle. There are three different kinds of arcs. There's minor arcs, major arcs, and semicircles. And I bet, without even telling you what those are, I bet someone could guess. Of course, it's on the board. Oh my. Moving on.
Oh, minor arc.
It's on the board. I'm not looking for anything.
Hey, let's hurry up.
A minor arc is less than 180 degrees. If it's less than half the circle, it's a minor arc. A major arc, like the blue one, is something that is over 180 degrees. And a semicircle is something that's right in the middle. It is exactly half of the circle. 180 degrees is a semicircle. And it will be formed by just the diameter. Questions about this vocab before I flip the slide? It was exactly half of the circumference. I sure can. Donovan's central angle. All right. You have a minor arc, which is basically a small arc. You have a major arc, which is over half the circle. Now, what's not pictured up here is a semicircle, which would be like exactly half of the circle. All right. And if you're looking at the central angle, Elijah, a minor arc will always be less than 180 degrees. A major will be over 180, and a semicircle will be exactly 180. Skipping it. Measuring arcs. The measure of this is how you would write the measure of an arc. Now, an arc is given by its endpoints. Okay? Now, this is arc AB. Now, you might be saying, well, couldn't AB be the minor or the major arc? And you're correct. AB could be either one. So, when in doubt, always pick the shortest arc available on those two letters. So, how I said arc AB, you will assume it's this minor one. Get that up, Malik. Thanks, sir. If it was the major arc, bless you, if I wanted to mention the major arc in this picture, I would need to include the other dot on that arc. So that would be arc ADB or arc BDA. So, if it's just two letters, you assume it's the minor arc. If you need to declare the major arc, you have to go through one of the points. So that'd be BDA or ADB. This is how you write an arc with a little swoop over the top. Okay? And when you're out talking about the measure of an arc, it's M of that arc. That's just how you write the measure of that arc. And the measure is nothing more than the central angle. The measure of an arc is nothing more than the central angle. So the measure of minor arc AB would be what, McLevin? What would the measure of minor arc AB be? That's right. Clay, what would the measure of the major arc ADB be? Exactly. It's just the central angle, and you can usually subtract to get them. Which leads us right into our next, just kidding, no it doesn't. Alright, find the measure of the given arc. What is the measure of arc RS? Stacy? 110, very good. What about the measure of arc RTS? Sage? What's the measure of arc RTS? Just RT would be 180, but not RTS. You have to end at S. but you just go through T. You need a calculator? Well, she obviously knows how to get it just on a calculator. You know what it'd be? What's that? Arc TS would be 70, but arc RTS is 180 plus that 70, which would be 250. Very good. 250 degrees would be arc RTS. You start with R, go through T and S. Basically everything but this 110. How many degrees are in a circle? So just subtract 360 minus 110. What about arc RST, Donovan? Very good. 180. And therefore, that would make that minor or major or what? In my circle. Very nice. Very, very nice. Okay. Arc addition. You don't have to write this down again. It's pretty much fairly common sense, but nonetheless. If you have two adjacent arcs, they actually wanted me to take time in this lesson to describe adjacency, but we've already done that half the time. So that's just two things that are neighbors of each other. If you have two adjacent arcs, then the measure of the grand arc, ABC, is just the sum of the two minor arcs, AB and BC. So that's fairly straightforward. You actually just did that in the last one. So, all right. A recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. The results are shown in the circle graph. Find the indicated arc measure. Who can tell me the measure of arc AC? Arc AC. Need a calculator. There they are. AC.
I know.
All right. It is 137. Arc AC is the sum of those two smaller arcs. Oh, really? You think you do? Well, in that case, Elon, what is the measure of arc ACD? How am I going to find it? Or you can just tell me the portion. Oh, yeah, very good. Didn't see it. ACD. Excellent. Very good. Measure of arc ACD is this entire thing. Now, how else could they have labeled arc ACD? They didn't have to call it ACD. They could have labeled it what? No. You have to end with A and D. But they could have called it ABD, would have been the same thing. ABCD, couldn't say you could have to just use 3 letters. So, just FYI. What about C? Arc ADC. The other one is Becca, what is arc ABC? Excellent. Arc ABC is 233. From here through D into C, add those up. Lastly, arc EBD. Root. EBD. What do you think? Maybe Elijah or Donovan wants to brother.
Well, I was thinking that, but I had to make sure.
We've only got 5 more calculators. Very good. 299. EBD. Now there are 2 ways. You could have added all these up. What would have been a shorter way than just adding all these up? 360 minus 61. EBD is everything but that portion. Very good. Excellent. Observation. Things like that can really save you time in this lesson. Really. Identify the given arc as major, minor, or semicircle, then find the measure. Blake. Yeah. Arc TQ. Major, minor, and what is the measure? say 120? Good. It is minor because it is less than 180, and it is 120 degrees. What about number 2? QRT. Ooh, jumped right off the deep end into a potentially difficult one. Madison, what do you think? QRT. Sorry? Well, QRT starts here and goes all the way around to here. It doesn't do the whole thing. It stops here. It goes from here to here. .240. Is it minor, major, or semicircle? Major, because it is over 180. Very good. Very good. Malik? What on number 3? TQR. TQR. It is. Therefore, its measure is 180. Moved in. Number 4, QS. Ooh, that's tricky because it didn't technically get us started. First, you just want to take a stab at it? QS? Okay, why don't you know? What's hard about this one? Yeah, one of them is missing, right? What do all degrees in a circle add up to? So, couldn't I find out what this is by adding and subtracting? Add them up and subtract? Do that. And let me know what that last piece is. That's what I got. Now can you well, that says 100 degrees, but my zeros and my degree symbol are the same size. Now can you tell me what QS is? It is. And it is minor, major, or semi. Very good. We don't have to do the last two. Does anybody have a question about what we're doing? We're not done. I still got 3 more slides, yo. Number 9. Congruent circles and arcs. Yeah, again, you don't have to write this down, but isn't it possible for, like, if we're just talking about the angle, couldn't half of this circle be 180 degrees and half of this circle be 180 degrees and half of this circle be 180 degrees? Yeah. Yes. But so you can't just say those arcs are congruent. They're obviously different sizes because they're all different size circles. So what this says is that congruent arcs have to come from congruent circles. They have to come from congruent circles. If the circles are a different size, therefore if the radius is different, then the arcs aren't the same. So, what about, which one up here is most obviously going to have 2 completely different arcs? You're looking at the 2 red portions on each picture. Which one up here is most obviously not the same arc? Jonathan. You're right. Even though they're both 90 degrees, this one is a much smaller arc than that one. So B are not the same. What about A? Are they congruent? Yes, they are. They come from the exact same circle, and they have the same central angle. That's the kind of thing you look for. Are their circles the same size, and do they have the same central angle? Last but not least, C. What did I call them today? Elijah. What about C? Are those congruent arcs or not congruent arcs? Very good. Very good. Central angle is the same. And even though it doesn't tell us the circle is the same, it tells us the radius is the same, which is enough to know that the circle is the same. I'll turn it down the AC. Oh, it's getting a little chilly. It was actually really cold here this morning, so I turned on the heat and then it came on like. Questions? Yes, except part of today's homework is your ability to follow instructions. It's a worksheet with just a few problems from your textbook added on. Part of your grade is going to be how well you listen to the following. I want the problems from your book listed here. I want those done on the back of the worksheet, not on a separate sheet of paper. Take a look at that around, please. What?
On the back. There's a book for problem on that.
He knows. He's being on the side. If you can put it on the side of the worksheet, I will be impressed.
I don't understand.
No, you didn't. What were you writing on paper that was that thick? Oh my goodness. Oh! What is wrong? Stacy, you've converted to the dark side. No. Oh my. Really? Really? Did you just say that? When it's only 2 letters, you take the smaller one. So it'll be this one. Okay? Thank you, sir. Do those on the back. Whoa. Let's put on some tunes. What are you thinking, classical today?
No, taking opera. Taking opera today. Or Beethoven.
What? He has music? I love that movie. What do you mean I would love McLovin? No, I don't. McLovin wishes. Beethoven it is! Oh, dang it. This is actually Mozart.
Alright, now I don't want Beethoven.
Outrageous. Okay. What is wrong? Let's listen to some 90s music. Good idea, Mr. Crawford. That sounds awesome. Oh yeah, I swear. This came out when I was in the 5th grade. When I was in the 5th grade, this came out. You weren't. Hold on, what year was that? That would have been in 1994? What? What would I be? About when I was in 5th grade? It was really 1961. These are hair plugs. Of course, if you're going to get hair plugs, why wouldn't you get better hair plugs, you know? But, you know. Oh, I forgot to stop recording.